Okay, as you are seeing here, the blood reservoir, you are seeing some blood reservoirs in our body. One of them, until here from circulation, we know vein system can consider as a blood reservoir. But in parallel with veins, we have spleens, we have liver and large veins and skin veins you are seeing here. What about spleen? In brief, in the red part of spleen, we can say there is the blood. It's a blood reservoir. And generally, if I want to tell you, the spleen has two parts, red part and white part. Do you know the function of white part?
تستخرج الدفات
white pieces, the white pieces in here. And in the red part, as you know, when RBCs, most part of the blood is RBCs. When RBCs get old, they went to the spleens to digest and analyze the different parts of RBCs and can consider as some type of blood reservoir. This topic is not for your final exam, but I want you, because you are going to be physician, you have to know that why always we are talking about the heart and circulation with together. For example, cardiovascular. Always the cardiac or heart part is in connection to the vessels. If you want to be a physician in the field of cardiovascular, you have to know the function of heart, and in parallel with the heart, you have to know why vessels are so important in here. And I told you that's not for your final exam, but let's think about venous return. Venous return can be considered as cardiac output. Yes, venous return, amount of blood that empty into the ventricle during diastole. Venous return can be considered equal to cardiac output. The amount of blood that goes to the heart must go out of the heart. That is the rule in the heart. And which factors can affect venous return? I will tell you one situation. In the central nervous system regulation, the sympathetic activation causes a great contraction in the smooth muscles. We know most part of the smooth muscles are seen in the small arteries and arterioles. So, in a situation, I ask you to think about that. In a situation that sympathetic nervous system activates, what happened to venous return? Think about that. Activation of sympathetic nervous system mostly contract which part of vessels? At first find this answer. And then think about that, if that part of vessels contract, what happened to the venous blood and finally venous return? Who said increase? Why?
The volume of the blood.
Contract in which vessels? Sympathetic nervous system contract which vessels? Mostly contract which vessels? Arterial. Yes, arterial. Imagine if contraction in arterioles, what happened to blood flow in capillaries? What happened to blood flow in veins? What happened to venous return? What happened to cardiac output? The the relation of the cardiac function directly related to venous return. And venous return influenced by the same changes that we discussed these sessions about circulatory system. Can you see? In a very rare situations, when somebody got very emotional feelings or bad feelings, such as when you say some bad news to somebody, they faint suddenly. How? Because at that moment, sympathetic nervous system activate, and sympathetic nervous system mostly contract smooth muscles. Which part of vessels has a high smooth muscles? Arterioles. So arterioles in the whole body, because sympathetic nervous system is a general regulation system. So the whole arterioles in our body suddenly contract. And this contraction, it means that the blood flow in the venous system reduce. The blood flow reduced in the venous system, it means that the venous return reduce. Venous return reduce, cardiac output reduce. When cardiac output reduce, it means blood flow reduce. Yes, the reducing of blood flow is happen, and it means the most tissues, such as brain, is not cannot perfuse properly, and she or he faint.
What about the pressure? For example, if someone is faint, I think the pressure is decreased. So maybe
The pressure in the veins. In continue, I'm asking you to think about the pressure in the arteries. In that situation, what happened to the pressure of arteries? Arteries. When arterioles contract, the blood flow in the venous system reduce. Venous system. Please pay attention to the name of vessels. But blood flow in the arterial system increase. So blood pressure increase. So in that situation, that person has a high blood pressure in the arterial system, but venous return decrease, and finally cardiac output decrease. That's the consequence. That why in some situations, I told you, for example, very emotional situations such as bad news, the person suddenly faints because venous return decrease, the cardiac output decrease, even the arterial pressure is high. It's the connection between these cardiac and vessels. And as a physician, I told you that you have to know that. Why we are always saying cardiovascular, why we didn't say cardio specialist. We said cardiovascular specialist because both of them are connected together. And another term, if we want to see the connection of these cardiac and vessels, think about situation with cardiac ischemia or cardiac attack, cardiac failure, Cardiac failure, what's the meaning of cardiac failure, heart failure? It means that heart cannot contract as a normal. Yes, contractility in one part or in the whole part of cardiac muscles reduce. When heart cannot contract, the blood always still remain, a little amount of blood always still remain in the heart. Yes? True? When heart cannot contract normally, some amount of blood always remain in the heart.
Yes.
Yes? Please be in the class. It's so interesting topic. I said it's not for the final exam, but I want you to introduce this type of the connection of these two, because the basic of this block, the gathering the whole concept together, is finding the connection between them. Okay? So in the cardiac failure, the cardiac cannot contract, so always a little amount of blood stay in the ventricles. What happened to the atrium's pressure? Right, especially right atrium's pressure. right atrium's pressure.
If the heart can contract,
What happened to the pressure in the right atrium in the situation such as ischemic of heart or cardiac failure?
I think it's always
Increase, yes, because the some volume of ventricle is full by the blood, so the volume of atrium decrease, so pressure increase. The pressure in the atrium, in the total of the heart, especially in the right atrium increase. Okay, the pressure increase. So the differences of pressure between right atrium and vena cava will be decrease. Yes, decrease the differences of pressure. Imagine, let me say this by a digit. Imagine the right atrium's pressure, my dear friend. Imagine the right atrium's pressure. Think about this is a heart. And right atrium's pressure is -2. Sorry, my drawing is not good. Right atrium's pressure is -2 millimeter of mercury. Okay? So vena cava's pressure must be near to 0. There is a delta P to venous return. Always, because the vena cava's pressure is more than right atrium's pressure, we have a venous return. We have a blood flow from vein system, vena cava, into the right atrium. That's correct? Yes. So, in that situation, such as cardiac failure, the pressure in the right atrium increase. For example, it's going to be +2 or +1 millimeter of mercury. The vena cava's pressure still is 0. What happened to venous return? Stop. Yeah, you can see the venous return stop. Even the right atrium's pressure even reached to the 0, not plus, it's 0. Because the vena cava's pressure and right atrium's pressure is equal, there is a very, very low blood flow. Yes, you can see how cardiac ischemia can affect venous return and consequently cardiac output. Yes, cardiac output is based on cardiac function. So you are seeing the relation between vessels, circulatory system as a vessels, and the cardiac function in our body. So what do you think, what happened in this case, in the cardiac ischemia when right atrium's pressure is 0? The vena cava's pressure is 0 too. Most of blood trapped in the veins. Yes, most of blood trapped in the veins, and it means most of blood trapped in the venules, most of blood trapped in the capillaries. It means that the blood cannot move, so the blood trapped in the capillaries, veins, and venules. So, if the amount of blood increase in some parts, such as capillary, we have edema. Edema is filtration of extra blood into the tissues, extra plasma and fluids of blood into the tissues. Can you imagine that some people with some failure in the heart and ischemia in the heart, you can see the whole edema in the whole part of body. We have a whole body edema in that case. As you are seeing, they are related to each other. Isn't it interesting?
how can the volume of the blood affect of the pressure in the vena cava? Because
In the atrium, you mean?
yeah, because maybe it can.
Imagine that the blood trap in here. The blood trap in here. The volume decrease, the pressure increase. Yes?
So how can it affect the vena cava? Because of the can say.
I didn't talk about vena cava. I'm talking about right atrium's pressure. Okay. So imagine if the blood is still remain in the heart during diastole, the volume decrease, pressure increase. So the pressure in the right atrium increase more than 1 minus 2. Okay. So the vena cava's pressure is still remain 0. So the right atrium's pressure increase. And you are seeing that right atrium's pressure increase directly connected to venous return from vena cava and reduce vena cava's venous return. The good news is that this part is not for your exam, but I want you to give a sight to know the connection between these two parts in our body. Any question? So, let's start the third part of circulatory system. Until here, we know the function of arteries. They are keeping the pressure high as the large arteries, and the arterioles and small arteries, they are regulating the blood flow, proper blood flow into the tissues. In the vein system, we know we can consider vein as a blood reservoir because of high compliance, low distensibility, and we can change a huge volume of blood in the veins, and the pressure in the veins is not changed so much. So because of high compliance. And we talked about that how veins can send blood into the heart part against gravity and the huge volume and low pressure. So there is a third part of circulatory system, my dear friend, that is a connection between arterial system and venous system, that is a capillary network. Capillary network, in fact, is a main purpose of this circulatory system. And finally, our purpose is blood, is a proper blood flow in the capillary system to exchange gases and nutrients. That is the main purpose of this whole circulatory system. So let's see what is the, in this part, what are the anatomical and physiological parts of the capillaries. So let me ask you, please see this picture, and let me ask you about meta-arterial. This is at first let me introduce. This is arterial part, and this is venous part. And by schematic picture, you are seeing this here is capillary network or capillary bed. So we have a part named meta-arterial here. What do you think about the function of meta-arterial?
To make the blood transport from the artery to vein?
No. You are seeing so many smooth muscles. What? Control, regulate the amount of blood that should pass or should not pass, okay? Based on that tissue's demand, they because you are seeing they have a huge amount of smooth muscles, they can contract or relax to regulate blood flow into that tissue. So after arterioles, that is full of smooth muscles, we have another part named meta-arterioles that again we have smooth muscles in here too, and the proper blood flow regulation is one function of these meta-arterioles. The another part, my dear friend, is in the bottom, arteriovenous bypass, bypass or shunt. What does that mean, bypass or shunt? Do you know the meaning of shunt?
Yes.
What is the role of this part in the capillary bed? What do you think about that?
The blood
directly without any exchange, okay? Not exchanging and circulating blood in the capillary system consumes some time. From the first slides, we know that in the capillaries, the velocity is very common. Velocity and cross-section. The first section, the low. You said high or low?
Low.
Low, sorry, I think you said high. Sorry, excuse me. In the capillaries, the velocity of blood is very low, and it means it consumes some time. In some cases, we don't want to circulate, we don't want that time. We want to immediately blood shift from the arterial system into the venous system at a moment, at a minutes, by minutes. So this arteriovenous bypass is helping us. For example, when, if I want to tell you by an example, for example, in the cold weather. In the cold weather, we have a plexus and capillaries network beneath of our skin. But in cold weather, we don't want to reduce, we want to keep our body's temperature, and we want to reduce the blood circulation under the skin to keep the whole blood inside the core of our body and keep our body's temperature as a normal range, okay? So in that situation, the blood suddenly passed by this shunt from arterial system into the venous system on the skin, our skin, to send to venous system to finally keep this blood in the core of our body and not wasting our temperature, okay? Not wasting the temperature of our body. That situation. Generally, I want to tell you that sometimes we don't want to circulate blood in the capillary network. In that situation, the blood are passing through this bypass. How? By contraction of these smooth muscles. These smooth muscles completely contract, so the whole blood passing through this bypass into the arterial system.
So what is the difference if this is smooth muscle or not?
This bypass?
Yeah.
No, the bypass has no smooth muscle.
I asked about the effect. How can the effect of the smooth muscle, for example, if there is no smooth muscle, how can it affect of our body, for example?
The bypass, you are talking about bypass or general?
No, in general. I asked
In
about
general.
if the
So,
smooth muscle.
did you study chapter 17?
Yes. Yes.
Okay, so we know that the local controlling, yes? Sometimes we have local control. We have some agents, if you remember. What agents? For example, dilate vessels and smooth muscles. Agents. Come on, yesterday we discussed. Local.
Smooth muscle,
Yes.
contraction or relaxation, and then the vasodilation and
Vasodilators, local vasodilators.
Yes, one smooth muscle contraction.
Yes, name. Myogenic mechanism, no. Relaxation, vasodilation. You tell me? Histamine, carbon dioxide, bradykinin, nitric oxide, excellent. All of them locally controlling, okay?
It is like, for example, when the oxygen is high, so it is contract, and when the concentration is low.
Yes.
Yeah.
It's locally controlled,
Yeah,
okay?
remember.
So, my dear friend, we have different types of capillary related to their permeability. Do you know the meaning of permeability? Permeability. They can, if a membrane has a high permeability, it means that large molecules and even cells can pass through it. Even, and on the other hand, if I tell you that a membrane has a low permeability, it means that no large molecules or no proteins can pass through it. And we know in our body that gases, all gases, can pass through all membranes. Gases such as nitric oxide, such as oxygen, such as carbon dioxide, such as carbon monoxide, all gases, you have to remember this, all gases can pass through all membranes in our bodies. And the name of gas movement cross the membrane name simple diffusion. We have a simple diffusion that is a rule for all gases. So simple diffusion means the gases are diffusing or based on concentration. From high concentration, it goes to the low concentration. So there is no barrier for all gases. That is the first rule. And in the capillaries, we can categorize capillaries based on different permeabilities. Okay? For example, I can tell that the at least permeability related to the capillaries in the brain. In the brain, we have neurons. We know that most of neurons are non-replicating. There is no mitosis in the most of neurons in our brain. They are so sensitive. They are only protected by skulls. So we should protect these neurons, as you know. And one protection of these neurons is lowest permeability of capillaries. It means that this capillary has no permeability to any kind of molecules. Only gases can diffuse, and what is the main nutrient of our neurons in the brain? Glucose. Only glucose transport by its transporter. Glucose transporter, abbreviated as GLUT. Glucose transporter. Do you remember transporters in the cell physiology can transport it? Okay? In our brain, the endothelial cells of capillary has no permeability to any kind of molecules. They can transport glucose by transporters, and gases such as oxygen and carbon dioxide are passing by simple diffusion. That is the least permeability related to the brain's capillary. But we have another types of capillary with a little permeability. It means that we have a little hole or pores on the surface of endothelial cells. Imagine this is the capillaries endothelial cells. So we have some pores on the surface of endothelial cells. These types of capillaries categorized as fenestrated. We have fenestra. Fenestra means pores or holes. It's fenestrated. We can see this type of capillary in the glomerule of kidney. In the glomerule of kidney, if you remember, we need to pass waste products. We need to exert, for example, urea, or we need to exert creatinine. Most of molecules, waste product molecules must be exerted into urea. And we can see this type of capillaries in the kidney. And on the other side of these categories, we